Hello, hello. It is episode 4 of the webinar. I am Red, your host. Today we are going to be talking about metadata generation for NFTs. This is a step in our series where we've already gone over Solidity, we've gone over basic ERC 721 smart contract, and now we're going to look at metadata generation on our way to creating a minting Dapp, creating an NFT marketplace, and creating some larger full stack projects on Ethereum. So before we get started in the fun stuff, we're just going to give this a few minutes, let people join in. We're doing our webinars a little bit differently this week. If you remember in the past, we were just hosting them in our Discord. But now we are hosting them on YouTube Live, which means some people are coming from Discord, some people are coming from Facebook, and some will be on YouTube. So yeah, doing something new here. We think this will be a little bit of a smoother process for everyone. Let them get involved through whichever medium they prefer. And I hope some of you guys were able to join the Oasis webinar last week. Oasis Protocol, if you're not familiar, they are a privacy platform, and they came in here and they did a little webinar of their own, which was awesome. Big focus on privacy today. I don't know if anyone saw some news about Tornado Cash, but the U.S. government put them on the sanctions list, which is pretty serious if you violate that. But they are they're a privacy tool used on Ethereum and some other networks that has been around for a while, and seems like a bit of a rash decision. Kind of came out of nowhere, but yeah, with privacy in the spotlight, I'm sure our friends at Oasis are very aware of what's happening there too. But something interesting to check out, if you like to follow up on your news in the crypto space and whatnot. Yep. So if anyone is here in the chat, feel free to let me know where you're tuning in from. I'm usually tuning in from Denver. Today I am in Madrid, so a slightly different time zone for me, but nonetheless, we're here and we're going to learn about some Web3 stuff. Let's see, I'm going to have to cycle through the chats here because we got a couple of them, so I'm going to try to keep on top of all that. And the Discord is, going forward, going to be the main place that we're still keeping communications going. So just because these webinars might be on YouTube or somewhere else, the Discord is still going to be your best place to get in touch with me, Kim, Lucas, anyone else on the team. If you have some questions, if you have anything you want to bring up, or even just chat with some other people in the Hackers Club community, Discord is still your go-to place. Cool. Let me hop in this chat here. Awesome. Yeah, so I'm going to get started by just touching on OpenSea's standards. So OpenSea isn't the end-all be-all for NFTs. The name is associated with NFTs at this point in their life cycle, but it is just a centralized company that happens to be the big name in the space. It's the way people say I'm Googling something as a verb instead of I'm searching something. There are other search engines. There are other NFT platforms. But when you have a big one like OpenSea, they do have a responsibility and obligation. They often do dictate some of the industry standards because we kind of need to be all on the same page with these things. Otherwise, you're not going to be able to have your NFT listed on OpenSea and Rarible or multiple different platforms and have a consistency, for developers to be able to display that stuff. So we're going to look at OpenSea's developer docs to just get an idea of the metadata standards and what that looks like for someone who wants to come in, be a dev, and start building that way. So yeah, the metadata is all the information you're storing. We mentioned this when we talked about Solidity and how much code is actually being written to the blockchain. What is the size of my function? How can I make it more efficient? This comes into play with metadata too. You don't want everything stored on chain because a blockchain is not an efficient database. It is a reliable database, but it is not an efficient one in terms of I don't want to put a 1 gigabyte video on chain. That is, you're not using the right tool for the job if that's what you're doing. And it's going to be expensive. As we touched on previous webinar, it does the more data you're writing to the chain, the more money it costs, money in terms of gas. So what's actually going on chain is a pointer to your metadata, and your metadata can, you could stick that on AWS on a centralized server, spin up an Amazon S3 server, stick that in Azure, stick it wherever you want. But in the ethos of Web3, we often like to put it in a decentralized storage system, or something like IPFS. That's the most popular solution here. It stands for Interplanetary File System, which is just a fun name for a distributed database. Arweave is a project that handles distributed data storage. But in the spirit of Web3 with decentralizing things, that's how people typically like to store their data for these projects, and that's what we're going to be looking at here. So as a reminder, the token is on chain. The token contains a pointer to the metadata. The metadata is its own, typically a JSON file, set of parameters, attributes, and really whatever you're sticking in there, a name and maybe a background, an eye color, this, whatever you got. And then separate from the metadata, the image is its own file. So you have a pointer on the blockchain pointing to your metadata, and you have another pointer in your metadata pointing to your image. So we're going a few layers deep here, but it will make sense why you do that in terms of sometimes images need to be hidden. Sometimes they need to be updated with reveals and stuff. When you compartmentalize things and make things a little bit more modular and separate them, it will help you out in terms of changing factors without changing the whole thing at once. Cool. And I see from YouTube, we got Grid Junk Greetings in from Dublin, Ireland. That is awesome. Love that. I'm Irish myself. The red hair might give it away. Great to have you. Cool. So running through this a bit, implementing a token URI. This is token URI. URI is essentially a URL. This is what we talked about when we deployed our NFT contract on Pinata, and we not deployed our contract. We put some metadata up here on Pinata, and we were given a hash. So yeah, this loaded up here. We were given a CID. This is a hash. Whenever you upload something on Pinata or some other interface with IPFS, it will give you this hash, and that hash is your URI or your URL. If I am to, enter this folder, what it's going to do is it's going to bring me to a page that is set by that in the URL. So this is going to take a minute to load. Oh, cool. There we go. Cloud/IPFS/our hash. So our URI or URL, that's our pointer to where all this data is. Great. Now, yeah, ERC 721s and ERC 1155s are main ones. When queried, it should return a blob of JSON data. And that JSON data is really just a big old list. So to give you an example of what some of that JSON might look like, it might just be a big old file like this, where you just have one after the other for each token representing their different traits. Don't worry, we're going to go back to that later. I'll explain it a bit more. And this is what I talked about with those pointers. So you have a contract that has a pointer to some metadata. That metadata will have a pointer to an image. And when you have a Dapp like OpenSea, or maybe something we're going to make where we want to show people their NFTs in their wallet or show people what they've minted, that's what we're going to be querying to get that data. So it's not enough to say you own token number 76 in contract XYZ1234. We want to, take that token, look it up in IPFS or wherever it's stored, and we know where it's stored because our contracts here, if this is the contract we deployed last episode, if we want to go look at it and go into the read functions of it, we can say, what's the base extension? Oh, JSON. Cool. We know it's a JSON file, so we know how to read it properly. Maybe we want to get the token URI or the base URI or something like that. Like, these are things we're going to be able to find in here, not revealed URI. This is, again, what I mentioned, revealing and not revealing an NFT. So these are public functions anyone's able to interact with. So when we create our front end app and we want to query some metadata, this is how we're going to do it. We're going to say, okay, it's this number token. We're going to plug that in. It's going to give us the URI, or the CID, as we would call it, on Pinata on their dashboard, and we'd query it from there. And as these standards say, if I query this, it should just kick back a blob of JSON data. So now I, as a front-end developer, I know what data I'm working with. And that's why we want to work within these standards, because, okay, maybe we're just making our own app, our own web app that we're going to work with. We make our own app, but we want other people to be able to use this in the future too. So we want to make our work as easy as possible for other developers to work with. That's why we're going to follow industry standards, and that's why we're going to use OpenSea standards when we look at metadata. We're going to put it in a JSON file, and we're going to try to keep it a similar way to the way other people are doing it. That's not to say things can't be improved on. Obviously, you don't want to just do something because that's the way it's done. But it is nice to stand on the shoulders of giants. So after giving things a quick look, it's nice to see, all right, let me not reinvent the wheel. There is an established method for this. So here we are to the actual metadata standard. What you'd have is a description, an external URL, that might be your website, an image. This could be a Google storage. This could be an Amazon S3 link. This could be an IPFS link. A name and attributes. So just as I mentioned, your image isn't being stored in your metadata. You can't store an image in a JSON file anyway. So if you did a different file type, you might. We're not going to talk about SVGs here and a standard vector graphic image. We're going to talk about PNGs and JPEGs. So that's not something we'll be storing in there. And this is another look at some of these properties. Again, basic ones you're probably familiar with if you've worked with NFTs at all. A name, an array of attributes, like little things like a background color maybe. And this is how they would display on any of these dashboards. So, if I want to make my NFT project and I want it to look nice on OpenSea, I'm going to follow their standards so it shows up this way. Now, without going any more in depth into this, we will look at some actual metadata. There's not too much more specific stuff in here. I guess it talks about Arweave a little, which I mentioned is another storage system. Arweave has its own token and works more closely with Solana. But we are going to hop into this here now. Let me pull up my Visual Studio Code. Alrighty, so first, I'm going to show you a Python script that's used for just creating metadata. And this could be done with JavaScript. This could be done with Python. I do it with Python. A lot of people prefer JavaScript, but personal preference on what language you use. This is not that crazy of stuff, but typically what's going to happen when you're working with a project, let's say you're a freelancer and someone says, hey, I want you to build my smart contract. They're going to need help with the metadata too. They're probably going to have a big Excel file or something, or some master copy of what their metadata looks like. Maybe they won't. Maybe they'll have nothing and they'll say, we're making the art right now. We need to make it as we go. Either way, they're going to look at you, the dev on the project, who say, hey, we hired you to build this contract. Can't you help us with this other stuff? They're going to look at you to do this too. And it's fun. So you should know how to do it anyway. But what we're looking at right here is a simple script that all it does is it pops open a CSV file, an Excel file, and it's going to create a file for each row in that CSV. So this is the CSV. We're going to use it as an example. This has about 100 entries in it. They've all got the same description and stuff. This is from some example NFT project. And, they've got a list of traits up here on the top. This is what projects are going to come to you with. Someone's going to say, hey, these are the different traits all my NFTs are going to have. I need you to write the smart contract for this, and I need you to, help generate this metadata for all this and upload it on IPFS. They're not going to know you need to upload on IPFS. They're just going to say, hey, you're the dev, make it work. But these are the steps you're going to take. So assuming they give you one master file, you'd be able to edit it however you want. You can use Excel to kind of randomize things if it's all in order and you need to break them up. But essentially, what it's going to look like is they're going to give you a master file, and you're going to need to break that down. If there are 10,000 entries in here, I need 10,000 JSON files. That's not something you want to do by hand. That sounds horrible. So what we can do is solve that with a little bit of scripting. Now, if we take a closer look at this file, what it's going to do is open a file called ftotal, which is going to be a metadata file with everything in it, a total one. And it's just going to have an F file as well. So ftotal and F, and these are going to iterate through while every iteration, every single line creates a new F file and adds to the total file. And that's, we need to take all these rows. These are things I hard coded in because I've used this before. I'll put in the name, the description, the image, and then the array of attributes. As we mentioned in the standard, that's what OpenSea and other big NFT platforms are looking for. They're looking for a name, a description, an image, and then an array of attributes. So how might we create that? These aren't already in a big array, so that's something we're going to need to do. And we're going to need to take the rows for each of these things. So a little bit of customization is needed for a file like this, but it is very simple file scripting. So this is something, you can find something very similar to this on Google. If you say, how do I get a Python script or a JavaScript script to create a JSON file from a CSV or vice versa? And what this would look like if I ran it would be, let's see, I gave it some outputs. Total number of rows, 101. Field names are token name, description, image, background, etc. And it's writing the JSON files. So where did I tell it to put them? This metadata folder. And now if I pop this open, I've got 100 new files. Take a look at the first one. It's got a gray background. It's mosaic. If we'd like, we can change a couple files on here. And I'll call that new. And then, we can just run our file in here again. Get a whole new set. Hold on, which one did I change here? Yeah, we'd run them in there, get a whole new file again, and that's what it was. I'm reading from Pablo 3, so I'll go to the Pablo NFTs over here. Reveal this in my file explorer, open it up, and boom. I will call this background hacker background. And now, reading from this file, do a quick run, get hacker background. So this is just a quick way. Like I said, you don't want to be actually opening up JSON files one by one and editing them. If you get lost in errors like this, it's not going to be easy to debug it. So what I recommend is having a master file and just doing a little bit of file generation from there. So if, the project I'm working on, let's say I'm freelancing, the client comes to me and says, we don't want to call this, these eyes, the laser eyes anymore. We want to call them the Bitcoin maxi eyes or something like this. You don't want to go through these files one by one and change them. It's going to be hard to find to find a bug if you miss it. So what is preferable is to have one master file that you use to generate files from that. So that single source of truth is going to help you out a lot. Alrighty. Yeah. But as we mentioned before, not always the case. There are some different situations. Maybe you don't have a master file. You just have JSON files. Maybe you pick up a project that's in progress. These things happen. Documentation's not always there. If you guys have, been devs on other projects and stuff, or, worked with companies where you're inheriting some legacy code base, this stuff happens. Where's the master file? Where's the this? Why wasn't it made this way? You need to make things from scratch. Again, if you have all the pieces, you can use scripts to put them back together. So this is another file that's just running through a JSON file and breaking it out into different rows of a CSV. Again, could you do this by hand? Yes, but it's so dangerous. So we don't want to mess up our data that way. Um, that's why, in this sense, again, use scripting, use master files, set it all up that way, and then use whatever language you're more comfortable with. If you like JavaScript, use JavaScript. That's fine. I'm going to share the code for these two scripts, and we'll throw them in the description of the YouTube video after this is posted. So if anyone wants to use them, please do. If you're going to tweak them, I'm sure there's tons of improvements you can make on these, but it's a good place to start. Now, the other thing is, what happens if I don't have that CSV? What happens if I'm generating the images too? Now, the images are something we're going to look at next week more in depth, because it gets a little tricky when you're looking at, I have 20 layers of a Photoshop file and I need to generate them into pictures. And what you're going to do that way is look at a file like this, add some random functions, and instead of pulling these from an Excel, you're going to pull them from a local array. So what I might do is right in backgrounds here. And within that, I'm just going to add some. And maybe these are all the backgrounds we have for our NFTs, and maybe 10% of them are going to be purple and 40% red, 50% blue. If the client comes to us and says, these are the ratios, these are the way we want to make it, you can generate that from here. You would make an array for the backgrounds. You would make an array, the same thing that's with those ratios, that just has your 0.05, 0.40, 45, and your 0.50. You take the corresponding numbers for those. So now you're just using a random function really to pick a number between 0 and 0.99. And depending on your number, you're going to pick it from here. So again, the randomness behind these, when you're generating them, you can run it as many times as you want. Maybe you want to take out 100 of them and put them in customs. But that's what the NFT process, that's what the metadata generating process would look like. There are other ways to generate as tokens are minted. We're not going to touch on that yet because we're still looking at the more simplified applications of this. But if you are feeling ambitious, that is another thing you can do with this metadata to make things a little more secure. So a common problem is what people call sniping. And what that looks like is you deploy a project and a few people mint one, and now I can go on the contract. As we mentioned before, I can go on Etherscan, and on Etherscan, I can look up what the base URI is, and then I can maybe see the data for all of them in that folder. And then I can dig through them and I can say, this is the really rare one. The rare one is number 85. And I'm not going to mint any until I see there's 80 of them minted, and then I'm going to go scoop up the rare one. And that's not really fair. That's not really in the spirit of a random mint. Also, what if it's insider knowledge? What if I say, oh, you're the dev and you have a friend and you told the friend where the rare ones are because you made the metadata? That's a real problem, and people absolutely play the game like that and, engage in some unfair practices. So some people might say, well, I don't even want that to be possible. It should be random on the spot. And there are ways to randomly generate a token as you go. Now, that doesn't work if you say, well, I have special ones. The first 10 are custom made. They don't match the others. Sure, mix and match your methods, but the bottom line is doing it in a simplified way, as in what I'm showing, having all your metadata created beforehand is not the most foolproof, secure way. Just as the ERC 721 contract we made last week could be, improved upon. There are things like Azuki's ERC 721A, which has massive gas savings when you're batch minting. If someone wants to mint 10 of them, they'll save a ton on gas doing it with ERC 721A contracts. But one step at a time, we're going to do this iteratively, and we are going to revisit some of these topics as we go through this webinar. So if you hear, oh, there's a better way to do it, don't get too ahead of yourself. We're going to do it, and then we're going to iteratively improve as we go on here. Alrighty, so let's look at what we deployed last week on this. Yeah, so if you remember, after deploying a contract on Etherscan, it will ask you to verify it, verify yourself as the owner. And what that lets you do is interact with it. So if I want to connect my wallet here, I'm able to interact with some of these functions. Some of these functions are owner only, but I can change the base extension. Maybe we just have a text file. I can write to this and set it as that. Let's see, transaction gas util. Let's look at what we have here. Trying to call a function on a non-contract address. Let me make sure I'm signed into the account that is the owner of this. A4B. Yeah, it is A4B. Alrighty, here, we'll look at that in a sec. Yeah, first things first. Like we said, let me find, I have it bookmarked. I'll find a collection we all know so we can look at its metadata. Yeah, all of these are just an array of values that are stuck in here as such. So array traits displayed this way. OpenSea is expecting this, so it knows to look for them this way. But if the owner of this contract wanted to, if the owner of the Bored Ape contract wanted to, and if their contract had a function that allowed them to, they could update that base URI and point it to a new set of metadata, which people talk about how NFTs are immutable and can't be changed. That's true. The token is always there, but the metadata can be changed if it's only a pointer. So important distinction to make between what can't be changed and what can be changed. What can't be changed is that I am the owner of, token 7490. That's mine. What can be changed is what that picture looks like, what the metadata on that picture looks like. There are NFT games where your character can die and they'll be visually represented as such. And these are important things to know. There are even NFT projects I see where if you list your token under a certain price, they will change some metadata to it or mark it or do something that's not exactly in your power. So these are, one, good things to know as a developer, but two, good things to know if you are an investor or just using NFTs in the space in that sense. Now, if the owner of the Bored Ape contract wanted to, they could change the base URI to point somewhere else. And that could be a very similar metadata. That could be a completely different one. Like I said, it's not immutable. The data is still going to be there on IPFS, but it's just a pointer. So you're pointing to a new place. If you're familiar with C or C++, programming with those, and setting pointers for your arrays and allocating memory in that sense, when you're not dealing with a memory safe language, it's sort of the same thing because we're just dealing with data here is what's really going on with the blockchain and the metadata. Alrighty, now, as I mentioned, we're going to look at what it looks like to create the metadata from scratch with the image layers and uh, as I showed in that little bit where, maybe I'm going to, a simplified version, I'm going to stick, hard code an array in, hard code the statistics in. We're going to look at that with the actual images in the next one, because it's kind of a lot to create the images and take all these different Photoshop layers. That's something we're going to do with GIMP, which GIMP is an open source free version of Photoshop. If you're not familiar, there's a free open source version of every popular software you like out there. So you don't always have to get the paid version there. But what that's going to look like is take some ratios, take some percentages, and take all your values and just randomly shuffle them and keep creating. What you're going to also have to do while you do that, which we will show, is you're going to have to check, does this already exist? Maybe it can. Maybe it's okay to have copies, but maybe you don't want copies. And in your classic profile picture project, you definitely do not want copies. That's like your Bored Apes or something like that. You don't want two people ending up with the same token. It's more acceptable for something like a video game, or if you're creating other blockchain games, or even things with ERC 1155s, which is your semi-fungible token version. But that's another check we're going to have to make. As we talked about in Solidity, you're making checks left and right because the data can't be changed. Even with this, you can change the pointer, but you can't go and edit the metadata that's already in there. For example, if I want to hop onto Pinata right here and look at the metadata for episode 3, I can't edit or delete these files in here. They are stuck here in this CID, in this hash. And I couldn't, if I wanted to, as the owner of this data, edit them or change them once they're uploaded. They're here, and as we mentioned, just a dump of some JSON file. There's not really much in here. It's a, a background and a color. But that's all that's needed. And again, you get an image hash. So let's see, if we wanted to copy this one up here and stick it in instead. That is the corresponding image. And that's what OpenSea or any other platform is going to be pulling. That's what our dApps are going to be pulling, exactly from this direction. So, like I said, just some Python code, nothing too crazy with this. Maybe we'll do it with Python. Maybe we'll do it with JavaScript. Let me know. Let me know if you guys have a preference. If you're looking at front-end development, you probably know some JavaScript, but I feel like everyone knows some Python these days. So yeah, drop it in the chat if you have a preference which one we do this with next week. We can totally do either in terms of doing it with Photoshop layers as well. Anyone coming from a data analytics background, I'm sure you'd love to jump on some Python here. Python and R is all that's going on over there. Let me see. I don't even know which chat to pull up right now. But any of you have any tips, throw them in there. Throw them in the Discord if you miss it, and I can jump in there as well. So yeah, if you guys do have any questions about specifically what a client might ask of you, or if you think I skipped a step in this process or something's not clear, let me know and we can look at that again. But the chats here are open for any questions on other steps in this process. The metadata itself is it's an accessory to the contract. It's something you will probably do once for your clients and never have to touch again. The meat of it is going to be in any front end stuff you're making, or if you're just making an NFT contract, the smart contract itself, the Solidity code, nothing's going to be too groundbreaking in there. You just want to make something really clean and tight. And then a place for expressing creativity will be in the front end. You don't want to stray too far from what's known and understood on the smart contract, the metadata. If you're not following industry standards, other dApps won't be able to make sense of your data. They're going to be looking in the wrong place, and ultimately that's going to fall on you because they're not going to display your project correctly. So you're in a safe area that's not too it's not changing too fast when you're dealing with the early stage of the project, which would be your metadata and your NFT. You can't really deploy your smart contract until you have the NFT metadata anyway. Not that you want to make it public right away, but this is often a step that will come before you actually deploy your contract. You'll write it, but before you're going to deploy it to mainnet, you need to generate this metadata. And that might look like some back and forth, turning this into a CSV, giving it to a client, changing a few things for them, letting them change some things, and then regenerating your 10,000 or so JSON files. You're not going to want to put this on IPFS until you have a final version. Like I said, you can always get a new IPFS hash, but you can only store so much data on there before they start charging you money. And once it's up, it's not changing. So a few different ways to do that. Few different ways clients are going to ask you to do it. I will ask again in the Discord, do we want to use Python? Do we want to use JavaScript? That is about all we have for generating metadata, not including the images. And we're keeping these under an hour, so we're not going to jump into the images today. I'd love to hear any other questions you guys have. And yeah, thanks for tuning in. Make sure to join the Discord for future events. That's where you're going to hear about it. We post it on Twitter. We post it on Eventbrite, but Discord is where everything's really happening. So that's where you want to be to keep up with this stuff. I'm going to be here answering questions as they come in. The team will give me an assist if I'm missing any chats right now. If you're maybe throwing in a channel and I didn't see it, they'll get it to me, then I'll see it and answer it. Yeah. Otherwise, there is some cool stuff. There's some interesting stuff going on in the crypto space in general right now. I mean, Ethereum's merge is happening, and there's definitely some discussion over proof of stake versus proof of work, and if anyone wants to stay on proof of work, which would create a fork. Then you run into issues like Chainlink. Are they going to continue supporting DeFi protocols in proof of work? They say they're not going to. So what happens if you lose your stable coins and you lose your oracles? You're going to have to remake almost everything. It's going to render a lot of a forked network useless. So these are questions that are coming up. These are things that, if they happen, might create a ton of opportunities for developers. When people say, no, we don't want to work with this new change, we're going to do it ourselves. Well, guess what? Stuff's got to be rebuilt. So with a lot of things changing, this could be an excellent opportunity for people to find some work, get their feet wet, get involved with projects. Change is a time of opportunity. So it's exciting to see what's going to happen with the merge. And even with things like I mentioned before, Tornado Cash, it's kind of crazy. It's setting a new precedent on what's going to be cracked down on, what's going to be security, what's not. So it's definitely changing the space. I mean, even people's GitHubs got shut down that were working on Tornado Cash. So a little bit crazy, some crazy times in the Web3 space as devs right now. It doesn't look like we have any new questions coming in, so I'm going to be available. I'm going to be in the Discord right now and, this week in general, but feel free to pop in there right now if you have any other questions. Yep. Cool. All right. Thank you, everyone, for tuning in this week, and we are excited for the next one. Bye.